Hello students, today we're going to be studying acids and bases. As it says on the screen, they are everywhere. They're in your food, at school, in your house, and even inside your body. You have enzymes and other chemicals that can be acidic or basic and sometimes neutral. Today we're going to take a look at the properties of acids and bases, and we're also going to learn about the pH scale and how to measure whether something is acidic or basic. So the first thing to know is what is an acid. Make sure you have your note sheet beside you and that you are taking guided notes as it goes through this presentation. So acid is a solution that has an excess of hydrogen plus ions. So the H stands for hydrogen. We studied the periodic table last year, and you know that H stands for the element hydrogen. Plus means that essentially it's just a proton. So it has an excess of protons that are hydrogen protons in the solution. Another thing to know is that the word acid comes from the Latin word acidus, which means sharp or sour. So essentially, if something is acidic, it has an excess or a lot of H plus ions, and it becomes more acidic the more H plus ions it gains. So here are some of the properties. So if you were able to taste an acid, which not all acids do you want to taste, but they would taste sour. They conduct electricity, much like a metal. They're corrosive, so they break down things. They can corrode fabric. They can also cause problems if you get them on your skin. They can act to break down your skin and things like paper. They also react strongly with metals like copper or iron or another metal like tungsten. So some of the uses, we oftentimes eat a lot of the acids. Acetic acid is vinegar, if you have that on your salads or use that in cooking. Citric acid occurs in a lot of the fruits and vegetables that we eat, like lemons, limes, and oranges. Ascorbic acid is the vitamin C that your body needs to function. Sulfuric acid is one that we're not eating, and it's used in the production of fertilizers and plastics. It's also very corrosive to your skin or toxic to you. And in car batteries, there's a lot of acids. So now let's transition. So then what is a base? Well, a base is a solution that has an excess of hydroxide ions. So essentially, a base is lacking the protons or the hydrogen protons. So they can accept hydrogen ions, but they do not have a lot of the H plus ions like an acid, so something is basic. So another word for a base is alkali. So if you see alkali metals, we looked at alkali earth metals last year on the periodic table. So some of the properties of a base, it shares some with an acid. It can be corrosive, so it can actually burn your skin just like an acid, even though we don't think about a base being corrosive. If you were able to taste it, it would taste bitter, like baking soda. It feels slippery or slick. And again, like an acid, it can conduct electricity, but unlike an acid, it does not react with any metals. So some of the uses, a lot of the bases that you use in your home, you're cleaning with. So things like soaps or ammonia or other cleaning products. Most of the bases react really strongly with grease or dirt, and so that's why they're used as cleaners. Chalk and oven cleaners are other examples, and if you look around at things that you're cleaning with, you will see that they're basic. Also, your blood is basic, slightly basic, and that has to do with the chemical reaction that allows it to carry iron. So how do we measure these? So now that we know the properties, we measure them on a scale called the pH scale, and it's a small p and a capital H. It measures how acidic or basic something is. So the pH scale goes from 0 to 14. Acidic solutions have pHs lower than 7. So 6 or below, 6, 5, 4, 3, 2, 1, or 0. 0 would be the most acidic thing that you can get. If you look on the scale over to the left, you see hydrochloric acid is at 0, whereas things like a banana or milk might be slightly acidic, but it's not going to cause harm to you. A solution that has a pH of 7 then is neutral. Pure water without any chemicals or other dissolved substances in it should fall at 7. Everything above 7, so 8 to 14, are basic solutions. You can see where blood falls. You can also see where some of the cleaning products that you use, like soap, ammonia, and then drain cleaner is the most basic and maybe most caustic of them all. So here's the interesting part. So a change in one pH unit, so going from a 0 to a 1 or a 1 to a 2, represents a 10-fold change. So it's 10 times as strong. So something that is a pH of 1 is 10 times as strong as a pH of 0. You know by studying exponents and understanding that if something is increasing exponentially, it's 10 times more acidic than the last one. So for example, if one solution has a pH of 1 and another one has a pH of 2, the first solution is not twice as acidic, it's 10 times more acidic. As you go up, if you go from a 0 to a 2, you would actually be 10 times 10. So it's 100 times more acidic than the last increment. So it exponentially increases. So things that are at the either end of the scale are extremely corrosive and caustic.